The global build-out of artificial intelligence infrastructure is consuming capital at an accelerating rate. Current projections show an estimated $8.5 trillion dedicated to server racks, data centers, and advanced compute hardware. This chart directly compares that $8.5 trillion infrastructure spend against the global AI liability insurance market. The liability market is exactly $0. Insurance carriers write policies based on actuarial data. They cannot underwrite or price a risk that they cannot objectively measure. The risk currently hides in the verification gap, the operational void between asking, "Did the AI do this?" and "Can we mathematically prove it?" Trying to bridge this gap with software workarounds currently consumes between 30 and 40% of all enterprise AI infrastructure spending. AI hallucination and structural drift are not software problems that can be solved by adding more software layers. The only mathematically sound way to measure execution fidelity is through hardware-level telemetry, extracted directly from the physical server. U.S. Patent Application 19-637-714 outlines the architecture required to capture this telemetry. This system removes the software's ability to self-report its own accuracy. Instead, it captures an unforgeable reading from the silicon itself as the operation occurs. By securing this physical measurement, insurers finally gain the actuarial data needed to underwrite a multi-billion-dollar AI liability market. To understand why current software safeguards fail, we have to look at the exact moment a hallucination is born in the compute architecture. Every operation begins by fetching data from memory. The system then uses a completely separate software operation to verify that the data fetched is correct. This diagram illustrates the inherent delay between the fetch command and the verification command. That physical gap is where silent data displacement occurs. The data retrieved from memory is no longer the exact same data being verified by the software. The industry has deployed several multi-billion-dollar software patches to address this mismatch. Vector databases group information by approximate contextual proximity, but proximity is an approximation. It cannot guarantee exact, absolute memory placement. Retrieval augmented generation processes the output through an external filter to catch wrong information. However, this filter only acts after the silent substrate displacement has already occurred. Reinforcement learning from human feedback trains the model's behavioral output, but ignores the hardware execution layer entirely. Because none of these software layers can verify the integrity of the hardware execution, they cannot produce a legally binding actuarial signal. The alternative requires bypassing the software stack entirely and implementing verification at the bare metal level. Theta-driven moves the verification process down into the hardware substrate. This relies on the S equals P equals H framework, fusing the fetch and verify commands by enforcing that a data point's physical memory position equals its absolute meaning. In this architecture, the fetch command is the verify command. They occur simultaneously. A successful memory cache hit serves as an absolute guarantee of truth, requiring no secondary software check. The physical silicon detects data drift in real time, long before the software layer can process a mismatch. This single operation produces a definitive output. This diagram outlines the cryptographic trust artifact containing three variables, RC, TSC, and CAS result. RC represents the specific measurement of structural certainty. TSC provides the exact unalterable timestamp of when the operation occurred. And CAS result delivers the definitive verification directly from the hardware. Unlike the probabilistic confidence scores generated by software, this tuple is a rigid, mathematically proven record. By converting qualitative software hallucination into a quantifiable cryptographic number, this tuple acts as the first true actuarial primitive for AI. With the physical architecture defined, we must examine how this translates into market deployment. The business model operates with a decentralized foundation. The blueprints for the physical Genesis node hardware are open source and available to anyone. Operators can deploy these nodes anywhere, including remote coastal regions, enabling fully off-grid, sovereign compute capabilities. The proprietary value lies entirely in the FIM trust layer firmware. The firmware executes the physical measurement, converting a standard data center node into a verified, insurable asset. Node operators pay a licensing fee of $120,000 per year to utilize this layer. Because this firmware runs on any bare metal hardware globally, it scales with zero marginal cost to theta-driven. Immediate market demand for this measurement is being forced by the European Union AI Act. Article 14 establishes a strict, non-negotiable compliance deadline of August 2, 2026. By that date, enterprise operators must possess the ability to correctly interpret and verify the outputs of all high-risk AI deployments. The regulatory text explicitly prevents operators from relying on software self-reporting to meet this mandate. This legally mandates hardware telemetry, creating the precise data stream required by major insurance carriers to underwrite the space. European regulation forces the demand, the patented hardware framework creates the technological moat, and the first carrier to correctly price this hardware signal captures the market.